What's up, stats? This is C-Squared Mathematics. I'm Mr. Carlson, and we are going to be going through our last lesson for the week, wrapping up our normal distributions week and study. So 5.3, normal distributions and finding values. So now what we've learned is not just what the normal distribution is, how to interpret it, what z-scores are, and how we can actually use z-scores to find the area or the probability given any application question. But now what we're going to be doing is sort of working backwards. Given the area or given the probability, how can I find the z-score or value? Okay, so far what we've learned is just how to find the area or probability. So if you look on my screen right here where my mouse is, we found how to find this little area, what's shaded in purple, what that probability is. And of course, the probability we found the area to be right here is that. That was our last example from 5.2. Now what we're going to be doing is, what if we're given this, the 0.5105, and I want to find what my actual min and max are, what my actual z-scores would be. How can I do that? We're going to find out. So I'm actually going to skip the bell work here. We're going to go straight into the objective and central question. How do I find values given the area or probability under the normal curve or standard normal curve? Okay, so first things first, find the z-score that corresponds to the cumulative area of 0.3632. How do I do this? Well, I'm going to actually just go straight to Desmos on this. Okay, I'm going to go straight to Desmos. There is a way to do it just using the standard normal table, but it is exhaustingly stupid. Okay, and so I'm not going to show you how to do that. It's just a pain, and it's not accurate really at all. How do I do it? Well, if I want to find the z-score, I use this right here. This thing right here. It's called the inverse CDF. That's what I use, the inverse CDF. Okay? So how do I actually use it? Well, what I do here is, since I want to find a z-score, I know my standard deviation and my mean are going to be 1 and 0 respectively. So my mean right here is 0. My standard deviation is 1. Now what I want to do over here is I want to actually type in that area, that probability that I'm given. So erase. Let's type in 0.36. You start seeing stuff happening here, right? 32. So this right here will give me my z-score, and that's exactly what I wanted. So right here, z-score equals negative 0.3 and then 5. I'm going to round to 2 decimal places there, the hundredth place. Okay, and that's simple. That's all you need to do. So that's usually we just dealt with this, the CDF normal distribution calculator. But here, what we're going to be doing is actually just the inverse CDF. So the inverse is just kind of flipping it. I'm given an area now. I'm not finding it. I'm given an area, so I need to find the z-score. Okay, what if I say find the z-score that has 10.75% of the distribution to its right? What does that mean? Well, the first thing I need to do, guys, is understand what this looks like. So if I say 10.75 to its right, what that means is really this right here, this little area. So this right here is the 10.75% to its right, okay? So in order to actually do this, in order to actually figure this out, what I need to do is, first of all, I need to translate that percent, okay, to a decimal. So translate it to a decimal. And then the second thing I need to do is, after I translate that to a decimal, I actually need to understand that the z-score in the normal distribution calculator on Desmos calculates it left to right. It calculates it left to right. So it goes in that direction, left to right, okay? And because it does that, I need to actually account for that in my calculation. Otherwise, it's only going to give me this, what I have in white here, and not that. But I don't want that. I want this in blue, not white. Okay? So for instance, I'm going to show you. If I actually type in 0.1075, okay, that's negative. But here's the problem. On a z-score table, this is 0, and this is the positive numbers, and this is the negative numbers. What it actually gave me, guys, is this, negative 1.2 and then 4. That's what it gave me. So what it's giving me is this. But I don't want that. I want this to the right. So what I need to do now is do 1 minus 0.1075. Why do I want to do that? Because that will actually calculate everything else. Okay, it will actually subtract everything else from that. So then I go over here and I just do 1 minus. And then boom, I have my answer. So that is my answer. My z-score is 1.24. Now notice it is the exact same thing, but without the negative, okay? And that's totally cool. Like, you could do that. You could type this in and just make sure, oh, I don't want the negative. I want it to the right. So I'm just gonna make it into a positive. You could absolutely do that. If you did that, you just say, okay, that's negative, but it's to the right. So I want it to be a positive. So I make it to a positive. Or you can just do 1 minus and just boom, you have it right there, okay? Very simple stuff indeed. Let's try to do a similar one. Okay, let's actually erase this. Let's do a similar one. 96.16% of the distribution's area to its right. So again, I don't want everything to the left. So if I actually showed you, this is what it's going to look like. This is 0 because it's a z-score. I want 96.96 to its right. So really what I want is all of this. 96% of that. I want that. 96.16%. So the first thing I want to do is translate this to a decimal. So this is 0.9616. I'm going to go over here and do that. So I'm going to change that to 9616. Now this is 1.7. Now watch this. Right here is where my z-score where I want. But notice how that's below 0. And why do I do it right here? Because this is 96. This is 96%, but to the right. So I'm starting to the right here, and I'm kind of going over this way instead of going to the left and going over that way. So since I'm going to the right and going over that way, okay, this is 96%. Now, if I stopped right here, that would be 50% because it's symmetrical, right? So I need 96%, but this has to be a negative. But the problem is it gave me a positive. So I need to do, again, 1 minus, and then finally I get the negative 1.7 and then 7. So what's my z-score? My z-score equals negative 1.77. Okay, so it's tricky, this right business. Make sure that you know the difference. Here, it's technically to the left, but it doesn't have to say to the left because it automatically assumes that you will calculate to the left. And so will Desmos. But when it says to the right, you need to subtract that out. So make sure you actually do the 1 minus on Desmos right here and subtract that crap out, okay? Let's erase and let's do one more to kind of get a familiarity to it. I want to find a z-score, so it will be 0 and 1, just like that. 95% of the distributions between some negative z and some positive z. So what does that look like? That looks like something like this, where I have this as 0. I want to find this as my negative z, and this is my positive z. And I want to find all of this information in between. I want to find all that. Well, I already do know that. Sorry. That's 95%. What I want to find are these, my z-scores. Okay, so what is my negative z? Okay, so my z1, let's call that a z1. Okay, my z1 and then my z2. What is that? So this will be z1 and this will be z2. Okay? Wow, I can't write. Let's try it again. Okay, this right here will be z1. This right here will be z2. Better? Better. Okay, so what's z1? I want to find 95%, so watch what I do here, okay? There's a couple things I need to do when I do this, all right? Before I even go to Desmos, I need to understand, all right, I want to try to find a couple of areas first, like say in red. What if I find this area, like right here in red? What if I find that area? That will definitely give me Z, right? And if I find that, then of course what I can do is then find the other. But how do I do that? So the first step that I want to do, it's kind of hard. I want to take 0.95 and I want to divide this by 2. When I divide this by 2, okay, when I divide this by 2, I get 0.475. Then what I'm going to do is I'm going to take my second step, I'm going to take 0.5 because this whole thing right here where I'm dividing over, so this whole thing over is 0.5, 50%. Okay, I'm going to subtract 0.475 out from it. Why is that? Because really what I'm trying to find is what's in red, because this right here in red is what I don't want. In red is what I don't want, okay? And don't get confused because I'm not looking at that graph. I'm looking at this graph. Okay, when I do that, what I get is 0.025. What is that? So that value right here, 0.025, that value is actually what's in red. Okay, that's what I just found. So that value in red is what I just found, okay? So I had to divide first by 2. After I divided by 2, I got my 2 separate things, but then I need to subtract by 0.5, okay? And then I got that, all right? Does that make sense? There's another way you could do it. You could just simply do, whatchamacallit? You can simply do 1 minus 0.95. You could do it that way too. You could do 1 minus 0.95, and then you would get 0.05. And then what you would do is you would divide that by 2 to get 0.025. You could also do it that way. What happened there? You could also do it that way if you wanted to. Okay, maybe that's more intuitive to you. It does not matter. But that's not my answer, by the way. That is what I'm going to be using to find this. So the first thing I'm going to do to find Z1, I'm going to do inverse CDF of 0.025. And then this one, I'm going to do inverse CDF on Desmos, inverse CDF of 1 minus 0.025. Because again, I want the onto the right. So this is like the right side. So Z2 right here. This is Z2 and that's Z1. So we can actually say that. So let's actually erase all this. And let's actually write that. Okay? Because this right here is Z1. Okay? And this right here is Z2. And I want to find that. But Z2, since it's on the right side, I need to do 1 minus. All right? Okay, so now what I do is I go over here and I want to kind of, since I'm already at the 1 minus, let's do that first. So 0.025. And so now what my z-score is, this equals 1.96. So that's my first answer. Smiley face. And then when I actually erase this 1 minus, I get a negative 1.96. So that's what that equals, negative 1.96. And that's my z sub 1. Okay, so that one was definitely a little bit more complicated. Definitely, I understand that. It was a little bit more complicated, but just follow the steps and I'm sure you'll get it right, okay? Divide it by 2 or minus it by 1, and then subtract by that answer that you get or divide by 2. Okay, either one. If you want to use it this route and then do it that way, you can. If you want to do it that way to find 0.025, or if you want to do it this way, it doesn't matter. You'll always get the same thing. Just use the same formulas, just interchange the values. And then go over here and type that in just go to Desmos and type in your answer. Whatever you get in the box, you're going to type in literally verbatim that. This, boom, or 1 minus that, and then you'll get boom, 1.96. Okay? Sweet. So now, how to find a percentile. A percentile is actually very, very easy. And so I'm going to kind of knock these out really, really quick. How do I find a percentile of 5? Well, percentile of 5, I'm actually going to change these into decimals. So I'm actually not going to write anything down because I want to go fast. I'm not going to write anything down. You're going to be writing it down. And we want to find the z-score. So z-score gives me a mean of 0, standard deviation of 1. So I'm not going to change that. What I am going to change is this, okay? So I'm going to change that. Now, this right here, this is the only thing I'm going to be writing down, is going to be 0.05. This right here is 0.5. This right here is 0.9. I'm changing them to percents. So 0.10, this is 0.2, and this is 0.99. So what I'm doing here is I'm changing them to percents. Okay, so when I change them to percents, that is the answer, or sorry, that is the percentage that I'm going to put in for right here. So let's do that. So 0.05, that's my answer. Okay, copy it down, round to 2 decimal places. So negative, let's do negative 1.64. So negative 1.64 right there. Okay, I want to do 0.5, so now I'm going to erase 0.5, 0, which shouldn't surprise you. Why? Because your actual function here, if I change this to 0 and then 1, your actual function is and has a mean of 0. So what it says by 0.5, if I say 0.5 here, oh, sorry. Let's do, yeah, it should be 0.5. Not. I see. I do. Yeah. So if I give you 0, because it's inverse, right? If I give you that to 0, it gives you 0.5. But that's the area. So if it goes from negative infinity to 0 right here, I get an area of 0.5. Now, or a percentage of 0.5. Now, if I'm given the percentile or percentage of 0.5, this actually does the inverse and gives me the value of 0. Does that make sense? So it's just a flip, and that's what 5.3 this lesson is all about. All right. Now let's do 0.9. So if I do 0.9, I get that. So 1.8. So copy that down because that's your z-score right here. Okay, this will actually be your z-score is 1.8. Okay. If I change this to 0.10, I get negative 1.28. That's my answer. If I change this to 0.2, okay, because I'm just going to B now, right here. If I change that to 0.2, I get negative 0.84 as my z-score. That's my answer. And then I go to 0.99, 2.333, because that 6 will round that 2. So it's 2.33, because that 2 will be rounded to a 3 right there. 2.33. And that's going to be my answer. Very simple because you're just plugging stuff in. Okay? So now let's erase and let's get on to our next things, our actual last thing that or our second to last thing that we're going to be doing. All right. So what we're going to be doing now is transforming a z-score to an x value. So we have a z-score and we have an x value. Okay. How can I transfer a z-score to an x value? I already know how to do an x value to a z-score. How do I do a z-score to an x value? Well, if I have a z-score formula, which is x minus mu all over standard deviation, that now becomes x equals my mu plus my z-score times my standard deviation. Because all I have to do is multiply by my standard deviation and then add my mu over. So this is my formula that I'm going to be using. Okay, and we're actually going to be using it a lot. You don't need Desmos for this really at all because Math Excel will probably ask you to find an X value given a Z-score, and you can just simply just do this. I mean, it's very simple to do by hand. Okay, so this is my kitty. I love her. She's amazing and so fat. Oh my gosh, she's such a potato. Her name is Lowell. Her name is Lucy. Okay, a veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds. So far I'm going to go over here. I'm going to write down my mean is 9 pounds. With a standard deviation of 2 pounds. So standard deviation of 2 pounds. Okay. First weights. Find the weights of X corresponding to the Z-scores of 1.96, negative 0.44, and then 0. So let's do the first one first. X equals, just following this formula, X equals my mu plus my Z-score times my standard deviation. That's my formula I'm following. So my mean is 9 plus my Z-score is going to be 1.96 and then times my standard deviation, which is 2. Okay. What I get out when I multiply this is 12.92. I trust that you know how to plug it on the Desmos and you can literally type this in. So I'm only going to show you this once. So I can do 9 plus the 1.96 and then times 2. And then get 12.9. That's all you need to do. That's all you need to do. Okay? All right. So that is my first one. And of course, this is in pounds. Okay? And so now my second one is going to be X equals 9 plus, I have negative 0.44 and then times 2. What that equals is 8.12 pounds. And then my third down here at the bottom, let's squeeze it. So this is 9 plus, and then I have 0 and then times 2, which of course is just 9 pounds. Now, we want to interpret this as much as possible. So what does this mean? Well, if my mean is 9, this right here is above my mu. So this is above my mean. This one is below my mean. And then this one is actually equal to my mean. Okay, equal my mean. Okay, so that is how you interpret your results as compared to your mean. Very easy stuff, right? Just simple plugging it in. Just use Desmos. You don't even need to use this calculator. Just plug it in using Desmos and you got it. Or any calculator, really. Veterinarian records the weights of dogs treated at a clinic. Weights are normally distributed. So my mean is 52 pounds. And then my standard deviation is going to be 15. So I'm going to underline those. Okay. And I want to find these Z-scores. So I have X equals, I have 52. Okay, that's my mean, 52. And then plus, and then I have negative 2.33, and then times 15. What does that equal? That equals 17.05 pounds. And clearly, this is going to be below my mean. That's below my mean. Okay, that's how I interpret that. So now X equals 52 plus, I have 3.10 for my Z-score times 15. What does that equal? That equals 98.15 pounds. And this is, of course, above my mean. So that is how I would interpret that. It's above my mean, okay? And then 3 is going to be X equals 52. That's my mean. And then times my last Z-score, 58. And then, or plus my last Z-score times 15. Sorry. This equals 60.7 pounds. This is my average, my X value, and that is, of course, a little bit above my mean as well. Okay, awesome. So that is how you transfer a z-score or an x value into a z-score, an x value into a z-score. So now what we're going to be doing is finding specific data values for any given probability. And so it's exactly what we've been doing a little bit just with z-scores, but now we're going to be doing an x value. So let's get to it. So scores for California police officer standards and training tests are normally distributed with a mean of 50. Now notice now I'm not going to be using z-scores, so my mean is changing. Okay, so the first thing I want to do is actually write out my mean. It's going to be 50. Now what's my standard deviation? I need to know that. It's 10, so I'm going to write that down. Okay, now we want to know the top 10% and then what is the lowest score an applicant can earn and still be eligible to be hired. Because this agency will only hire the top 10%. So what's the lowest score that you can actually get? Okay, within the top 10%. So the first thing is first, I'm actually going to draw a basic normal distribution to see what's happening here. Okay, so right here, my mean is actually going to be 50. Okay, my mean is 50, and now what I want to find is the top 10%. So this little guy right here, that's really what I want to find because this is what we call the top 10%. Exclamation point. Okay, that's the top 10%. So how do I find that? Okay, what is this value here? Okay, that's what I want to know. So there's a couple things to do this. All right. Well, first of all, I can change this x value into, I can change the x value. I can find the x value by finding the z-score. Okay, I can do that. Or, actually, you know what? I'll probably do that, but I'll show you. So first of all, I want to find what this value is. What is that value? Okay, that's really the value I want to find. Okay, so let's actually start plugging this in and try to find what is the top 10%. So the first thing that I can do after that is I'm going to try to find an x value. So I want to find my mean, which is 50, okay, and then plus my z-score, and then times my standard deviation, which is 10. Now what's my z-score? Now we can go to Desmos right now and type in my standard z-score, 0 and 1. If I take the top 10%, okay, so 1 minus, because it's the top, so I need to do 1 minus 0.10, I get 1.8. So when I do 1.8 right here, that is my z-score. Now that's not my answer because I want an x value. I don't want a z-score. I want an x value. So that's why I'm using this formula. So now when I actually plug all this in and I simplify it, this is actually going to be 62.8. So 62.8 is the lowest score that I can earn. That's my answer. The lowest score that I can earn to be eligible to be hired by the agency. Now, I could do it that way, or what I could do is this way. Instead of actually switching and finding my z-score and then plugging it into the formula, I don't need to do that at all. I don't need to find my z-score and then plug into the formula to find that 62.8 is that answer. Okay, that's what the question mark is. What I could do instead is type in this. Okay, follow me on Desmos. I can change those values, my standard deviation and my mean, to be what they give me in the problem. So 50, and then comma, and then my standard deviation is 1. Now, what do you know? I get the exact same answer. So my other thing is I could just use Desmos all the way through. Okay? All the way through. I can just use Desmos all the way through. And that's what I'm going to do in the next example. I'm not going to mess with the z-score stuff. I don't need to transfer to a z-score. I'm going to cut out the middleman, as it were, and just go straight to Desmos. So my next example. In a randomly selected sample of women ages 20 to 34, the mean total cholesterol level is 181 milligrams per deciliter. So that is my mean. So I'm going to write that down. My mean is 181. What's my standard deviation? My standard deviation is 37.6. So I'm going to write that down, 37.6. Assume total cholesterol levels are normally distributed. That's totally fine. Find the highest total cholesterol level of a woman between 20 to 34 that they can have and still be in the bottom 1%. So what does that mean? Well, if I graph this out, the bottom 1% looks like this. This is like the bottom 1% here. Okay? So this is the bottom 1%. Now, I want to find that. Now that it's left to right, I don't need to do 1 minus over here, right? I don't actually need to do that at all. So I'm actually going to erase this. I don't need to do the 1 minus at all, but I do need to change this stuff. So what is my mean? My mean comes first, so I need to change that. My mean is 181. And then I go over here and I need to change my standard deviation to be 37.6. Now I scroll over, watch. What I scroll over to do is I actually type in the bottom 1%. Now what's 1% as a decimal? 1% as a decimal is 0.01. Okay, so that means I type in 0.01, and of course that is my answer, 93.5. So 93.5. That right here is, okay, the highest total cholesterol level a woman can have while still being in the bottom 1%. Okay, because this is milligrams and then per deciliter. This is the bottom, the top milligrams per deciliter that a woman can have during her age while still being in the bottom 10%. Sorry, bottom 1%. I hope that makes sense. Very applicable mathematics. I love this. Okay, so 5.3, you're only using the inverse calculator here. We barely use anything with the CDF calculator at all. Okay, just letting you know. We didn't use it at all. Okay. But 5.2 and 5.1, you are going to be using the CDF calculator. When you want to find an area or a probability, you will be using the CDF calculator. If you want to find area or probability, If you're trying to find area or probability, you want to use the CDF calculator. If you want to find the value or the z-score, okay, the x value or the z-score, I want to use the inverse CDF calculator. Okay, what did we learn? We learned how to find a z-score given the area underneath the normal curve, and also how to transform a z-score to an x value. And then last, we found how to find a specific data value of a normal distribution using technology given a probability. If you have any questions at all, please let me know. Okay, you do have a quiz review that's worth extra credit over the weekend, but of course you don't need to do that at all. But until next time, guys, this is C Squared Mathematics. I'm Mr. Carlson. Make sure to like and subscribe. See ya.